So in qualitative data, we learned last time that how we describe the statistics through tables, through graphs, through numbers, especially in number form. Whereas in quantitative, it's a bit different than the qualitative. Like tables are in a different way. First, we have to draw the frequency distribution, and then we go for its histogram to see the distribution of the table. Yeah. So we have learned about different kind of tables, how to plot them through histogram. Um, we didn't talk about whisker plot, box and whisker plot, but we talked about the scattered diagram, which is like dot plot. In quantitative statistics, the numbers can be displayed through measuring central tendencies, which are the averages. Most importantly, mean, especially when the distribution is symmetric. You must know about this. Then we learned about some important key points in the distribution. That's the distribution where the whole area lies under one. And if it's symmetric, then we follow mean. Otherwise, if it's skewed, we follow positive skewed, or negative skewed, we follow median. And if it's like bimodal is like any kind of distribution which has two different distribution to putting together as a one distribution. That's a bimodal. We will also learn about this. If we have this kind of distribution, then we go for the mode. Then we measure how to measure spread, how to measure the dispersion from any variable y1 from its mean, or y1. Why mean? Because we say in symmetric distribution, it represents the whole distribution equally. That's why we take the derivative of mean. Um, Range is usually helpful in a bimodal. IQR is help in skewed, positive, or negative skewed, whereas variance is really helpful in a symmetrical distribution. And in the spread, we learned how to take coefficient of variance and coefficient of skewness as well. What exactly their respective interpretation? That is to check. So can you tell me what is the interpretation of a variance? Oh, sorry, coefficient of variance. Why do we calculate coefficient of variance of one set and of any other sets of the series? Can you tell me? Yeah, I'm sure that you all of know that coefficient of variance is to check the consistency of the data, that which data is more consistent. For example, we took an example of there are results, econometric results of two courses. So I have your marks, so I can calculate the coefficient of variance. I will first need to get the mean, and then coefficient of variance of both the classes, and then I can be able to say that class 1 is consistent than class 2. So that's why we need coefficient of variance. So to check the consistency. And skewed, coefficient of skewness, we need to check the correlation of the data points respectively. Now you know the basic about mathematical foundations of the data and distribution. Actually, not only mathematical, but also statistical, because this is all about statistical. And the one we have learned before, and which means like matrices and differentials, those belong to mathematical functions, probability, and probability distribution, density functions, probability and cumulative density functions, quantitative data, how to describe qualitative data. We will also learn through EViews that this comes under the statistical basis of defining the data. So what you know is the very nature of distribution and important mathematical rules to analyze further these natures, especially when we are talking about numbers. So numbers have a really important and they play a really important role in interpreting and defining the data set. So that's all about what we have learned so far. If you have any question, you can come to me anytime. No worries about understanding different like differential matrices, probability, and everything. Today, we will go further to look at the linear relation. So we will start to learn the basics. We will start to learn the basic of econometric modeling, right? So modeling is very important. What is a modeling? Again, modeling means like defining something in a perfect way. That's it. So what is econometric? You already know that, right? So what is econometrics? Econom means economy, any relationship in an economy, and metric, you know what is metric. Metric means measure. So that's right. Econometric means to measure the economic relation, and the first thing should come in mind should be a regression. What exactly regression is, why do we need it, what are the other measures which can replace regression, but regression is better than those measures, why, all this we're gonna talk today. So first you need to know that it's clear that econometric means to measure the economic relation and to measure any relation. For that, we first set a model and then apply or assume that model on overall situation. And that's what we do in any case. Take like an example of any kind of modeling. You know, with the word model, maybe comes also in the mind about the fashion industry. Like there are models in fashion industry. So what exactly model means? Like let's take example from the clothing industry. You design some clothes and you say that it's a perfect dress for a male or any female, whatever you choose. For that, you need a perfect body to which can show overall like represent which can represent our population's body, and you can say that look, this cloth which I designed looks really good on this perfectly chosen body from the population. So that's why we call it model. So in statistics, in econometrics, in mathematics, whenever we are talking about modeling or model, so it means that we have our hypothesis, we have our intuition, and we say that this, and then we make a model which represents overall situation of any kind of a data, any kind of a relation, any kind of a situation in econometrics, mathematics, statistics. If we then we run our intuition, our thinking, our hypothesis, our claim on that model, and if the results are perfect according to our assumptions and whatever we have hypothetically claimed, then we say that it's an economic model and you can implement this on overall any kind of a situation or any kind of a data distribution in terms of economics or finance. So you understand what exactly what model and why do we also use modeling in econometrics and in mathematical terms. It has same meanings, so nothing different. We will learn about classical linear regression model. Let me tell you a little bit about this, a review, an overview, what we're gonna do in this section. Um, First, we will learn about as you can see on the slides. You're gonna learn. We're gonna learn about classical linear regression model, but mostly we're gonna do it. We're gonna use the whiteboard. Then we will see the difference between regression and correlation. because correlation is also something to measure the relation between two variables, to economic variable, to financial variables, on to any kind of other variables. But then why do we need regression? Why not what's the difference between regression and correlation? If both are like representing the same thing. We will start doing simple regression and how to do it in the EViews we will practice as well. So we're gonna under this section we're gonna start using EViews, especially regarding to the estimation techniques and modelings. How to estimate the model. First we're gonna make the model. That was a theoretical, and for that you need to know about the data and distribution, which you already have learned. And now we say that how to model this, how to linearly what is the linear shape of this, and how to estimate then that one. So we're gonna start estimation today. What are the key assumptions, some important rules, concepts? This first includes OLS, very basic. O means ordinary, least square. It's a basic tool to measure the linear regression. You already know what is linear, right? Linear means a straight relation, either positive or negative, but it should have a straight line in a relationship when we plot it. What are the properties of OLS? What exactly standard errors are? I mean, what is disturbance, population disturbance, or standard error? Then in second part of this section, we will talk about the statistical inferences. Um, It will include our different ways of making an hypothesis. Hypotheses are the claims based on your intuition. You wanted to know any relationship or any kind of yeah, you wanted to prove it mathematically. That's a hypothesis, and we will see how it's practical implications with real life. For example, in finance and economic world, we will take some examples at a country level or at individual level, in a company level. What is the significance of any modeling? Significance means you should know the measure of relevance, that how relevant is this model is, like how important it is. For example, going back to the cloth examples again, if I design a cloth and I wear it by myself, which I'm not in a perfectly shaped body, which means my body is not that relevant with the overall population. It's not that perfect. It's not that ideal, which can represent the whole population. So if I wear that shirt and it is like maybe it's super tight to me or something like that. So because I'm a bit fat, so maybe it doesn't fit me that much. And if I wear that and I walk on the ramp, then probably people will say that this design is not that good. But actually, that's nothing with the design. That's about choosing the model. Um, so this is really important. So we will see that how important, how significant, and how relevant the model is, so that we know that this can be implemented in any situation. How we do hypothesis testing. Whatever we make a claim, we made a claim, right? Now it's time that how relevant as well, how to test our hypothesis. That is it, because sometimes we just make a claim and we are not sure that it's just like an arrow in the air. So for that, we need to test the hypothesis that our arrow should meet the target, means our claim should be sound, should be significant. We will do, first we will do, as I told you, we will talk about different types of hypotheses statistically, mathematically, how to make our hypothesis and what are the key steps in testing our hypothesis statistically. Then we will learn how to do it in EViews. So we will conclude this section with the EViews. Let's start today with the regression stuff. So this is the important one where we are. So I will turn on the camera a little bit in a while, but before that, I wanted to tell you some important description about. You already know now what is modeling and why do we do modeling to see that our chosen one based our chosen relations based on our hypothetical claims are sound and can be implementable on any kind of situation. Now, from the name regression, what is it? Can we say it is a relationship between one variable with other variable? Of course we can say, but not necessarily only one variable. There can also be more than one. So first and foremost, regression is the first and foremost tool to do regression analysis. Um, so this you already know. I think I will take you back on the whiteboard now. So, and I will move my chair as well. So you can see the whiteboard clearly, right? Now onward, you're gonna see my hand and the whiteboard. So we will try to take like 15 minutes for the EViews practice. If not, then we will do the remaining in the next class. So regression. First, we need to, this is the first, let's note down. I'm using the whiteboard so that you can also have to, if you want to take some notes with you, you should take. And that's why I'm using the whiteboard, because first and foremost, we can say whenever the regression comes, the word regression comes as an economic expert, as a financial expert, this should come into your mind that regression is first and foremost, very important, first and foremost tool to find out the relationship of one variable with another, with one or more than one other variables. So that should come in the mind first. Is it clear in reading the whiteboard? Just tell me yes or no if it's clear or not. So if it's not clear, just tell me so that I can write in a big letters. Try to write in a big letters. Okay. So, but hopefully that you can know. So we need a regression. We can say we need regression to analyze, to do regression analysis. We evaluate. Basically, what do? We always evaluate. Now, remember, I'm using the term evaluate. We evaluate what? We evaluate relationships. For example, if you and one is correlation, we will see that what's the difference between correlation and regression, the difference between regression. For example, you and your you have certain relationship with your friend. So if as a third person, as a third friend, I'm going to evaluate. Now, evaluate means when I can also make judgment that how important your friend is to you in your life. That if something happens to your friend, what effects it brings in your life. So that's an analysis. Based on that analysis, we're gonna make key decisions as well. And the first and foremost tool comes in the mind. That's a regression. So hope that you understand what regression is. Let's talk a bit further. Let's move a bit further. So after knowing the key definition, we should know that it also shows the direction, right? Any kind of direction, positive or means inverse, direct or inverse direction, along with magnitude. Magnitude means size. We can say both of these can also be known as with the correlation. Then why do we choose regression? So it means when I say direction and magnitude, it means it also shows me how the direction of one impacts another. So this is the direction of, let's say, y. This is the direction of x. So here I can also explain that how much decrease in this, particularly if we take this relationship, how much decrease in x brings how much increase in y, whereas correlation doesn't give me that. So that's the first difference between regression and correlation. Let's say we want to know that it's in this variable y, which is dependent not only one variable but more than one variable. So it doesn't only depend on x, but x is like 1, 2, and so on, xt or xn. Right? So in this case, a set of how the set of x um, right? So sorry, I got some bit distraction. Um, how the x set can define y or causes the variation. So if I can say, I can write down that how, let's say these are the different x's, means not only one, but more than one, x1, x2, and 3. So we say that how these x's impact or define the variation, the change in y variable. That's it. That's regression. The define not only define the variation, but define the causes of the variation in y. So remember causes of variation in y. So correlation doesn't tell us this. It only tells us the relation, right? It doesn't tell us that how much variation and what are the causes of the variation. That if which x increases, how much y will increase. So we call so here we have two major variables. One are the x's, y's, and one are the x's, means x1 and so on, xk. These have different names. You can also call them regressant, dependent, because this is dependent on the changes in x. That's why we call it dependent. Explained, because it is being explained by these variables. We already know this, but just I'm telling you this variable. And if this is regressant, so this is regressor. If this is dependent, this is independent. So you can use these are the same relationship, the regression terms with different names of x and y's. Now, what I'm talking about, that how much x is gonna impact this y series, there we also need to know. We also need to know the parameters. What are parameters? Parameters is a set of intercept and slope which defines the change in y. So in regression, there are two parameters. One is intercept. What is intercept? We will talk about this a little bit. And slope. So slope of each variable is different. x1, x1 has different slope, x2 has different slope, and xk, between xk and y, has different slope. So there's another concept which shows the relationship. Now let's talk a bit about correlation. But before that, let's have a 5 minutes break here, and then we will come at 6:05. Okay, so